Hi, I'm Frédéric again. Today, this is a very special episode of What's What. Big up to my Nexans colleagues. Thanks to them, I could collect all the objects from the set I'm going to talk about now. In every episode, you can see them behind me. It is time to have them in the spotlight. These samples are both representative of transmission lines, but they look very different because they are, on the one hand, overhead lines, on the other hand, underground cables. So why such a difference? In previous episodes, we already have described underground or submarine cables. The copper or aluminum conductor is insulated with polyethylene. The thick plastic layer is the insulation. The thicker, the higher voltage. This cable, for example, can withstand a voltage of 230,000 volts, which is huge. But other extra high voltage cables can withstand twice. The plastic insulation layer prevents the energized conductor from any contact with the ground. The power can be transmitted safely, and when live, I can even touch the cable surface. When a cable is designed with its own insulation system, this is an underground cable. It can be buried at the bottom of a trench. That's why you've never seen one. This sample looks quite different, with a much smaller diameter and lighter. The appearance is metallic. This is a bare conductor without plastic insulation. This metal conductor is suspended from pylons or lattice towers made of a mix of aluminum for good electrical conductivity and steel for the required mechanical strength. But question, where is the insulation? Look around you. The natural insulation is air. Overhead lines, the distance prevents from electric arcs. The higher the voltage, the taller the pylons. I'm sure you've seen plenty. In a previous episode, we have described this geek sushi roll, a slice of submarine cable to connect an offshore wind park to the grid onshore. This one, with a yellow over jacket, is even more special. This is a subsea umbilical transmitting not only electric power with copper conductors, but also hydraulic energy, chemicals, control data, and other functions. Deployed on the seabed, the umbilical connects an oil or gas platform to the shore. I promised not to talk about superconducting cables again, but please, if you allow me a second, stop me to take some You are probably more familiar with this kind of wires and cords. They are used in residential, public, and industrial buildings. Each time you plug an appliance into the outlet, remember, these wires are hidden in the walls and connected to the distribution network of your district. And if you like, you can create bouquets of electrical flowers as our artist did for the studio set. Maybe we could organize a contest for season 3. You understood that copper is gold for electricity. I mean, this is our best electrical conductor. Did you know that copper transmits electricity better than gold? It does. Silver is a bit better than copper, but not so much, and so much more expensive. Therefore, copper and aluminum are extensively used for electric wires. These metals are limited resources on Earth, especially copper, which reaches nowadays extreme levels on the stock market. Therefore, it is our responsibility to recycle these precious materials. A special thanks to my colleagues in the plant of Lens, who recycle materials such as copper, aluminum and plastics. And remember this paradox in the cable industry. Which champions would get the gold, silver and bronze medals at the Olympics of electric conductivity? Silver, copper, gold. Since copper is a strategic material, it is interesting for a cable manufacturer to manage the complete process of copper transformation. My colleagues have provided this copper slice from the continuous casting, which is the process whereby molten metal is solidified into a semi-finished kind of ingot. Then, this bar is heated and drawn through a drawing die as many times as needed to get thinner and thinner wires up to deliver copper wires barely thicker than a hair. These 3D printed mock-ups represent voltage generators from Nexans lab in Calais. They test extra high voltage equipment in extreme conditions. This one even simulates a lightning impulse up to 3.2 million volts. Do you have an idea of the actual height of this generator? More than 20 meters. That's it for today. I hope you enjoyed discovering the secrets of our studio set. Don't forget to subscribe and leave a comment. See you next time!